In this video, we're going to talk about tangent lines. And we've actually already talked about tangent lines a lot. We know the derivative, this thing we've been talking about for the last few weeks, is the slope of the tangent line. Right? And we also learned now that we can find derivatives using the power rule and some derivative rules. But the important thing is remembering we're still talking about slopes of tangent lines, even though we're doing all these tricks to kind of simplify the process. As we've seen visually, the tangent line is the line that continues the direction the function is going. So if we had this function, its tangent line here is kind of just what direction is the function going at that time. That would basically be a tangent line. And the tangent line is useful because it kind of tells you what your function is doing at this time. Sometimes you don't have the information after the point, so you just need to know kind of where is my function kind of going at that time. So finding the tangent line itself is actually pretty important. All right, so how do we find the tangent line? All right, so if you want to make a line, you need two things. So you need a point on your line, and you need the slope of your line. All right, so if you get those two things, you can put it in what's called point slope form. All right, so we have point slope form, where we put our y value there, our x value there, and our slope there, and that gives you the equation of the line. And then for our final answer, most of the time we're not going to leave our final answer in point slope form because there's a bunch of different ways you can write things in point slope form. We're going to put it in slope intercept form because for every line there's only one answer in slope intercept form. All right, so we have to know these two equations for lines and just kind of manipulate between them. All right, so here's the process. Let's find the equation the equation of the tangent line to f of x equals x squared minus 3 at x equals 2. So first thing is we need a point. If we think about the graph, the point of the tangent line is on the graph of the function. So to find the point on my tangent line, I'm actually just going to plug that x value into my function because then it'll give me my x value and the function gives me my y value. So the point is when I plug in 2 in here, 4 minus 3, and that's 1. So the point on my line is the point 2, 1. When I plug 2 into my function, I get out 1 for my y value, and that's going to be that point here where my tangent line just touches my graph. All right, so first thing to remember, when you're finding the point for your tangent line, it comes from the original function. And now we need the slope of our line. All right, and the slope of the tangent line is literally the definition of the derivative, so we know we're going to have to find the derivative. The derivative of this using the power rule is 2x minus 0 because the derivative of 3 is 0. So derivative is 2x. I plug in the x value I care about into my derivative, and I get 4. Right. So I get the point from the original equation, I get the slope from the derivative, I'm just plugging in that value into each of those functions, and now I can make my equation of my line. My y value of the point is 1, the slope is 4, and the x value of the point is 2. All right, so really that is the equation of the tangent line, but we want to just convert it into slope intercept form. All right, we want to convert it into slope intercept form. So there's two steps. We distribute, and then we add that 1. All right, so this is the slope of the tangent line. I would give us the exact tangent line for our function at that x value. And it would look just like that picture at the top. We have that single point where it's touching, and then the tangent line kind of skirts along the edge like that. All right, another example. Tangent line to g of x equals 3 over x at x equals 1. So our point, again, the point's going to come from the original function. So I'm going to plug just 1 into my function, and I get 3. So the point is, if I make x 1, my y value is 3. All right, next is slope. I find the slope of the tangent line. I find the derivative. The derivative is g prime of x equals, well, this one I have to do a little bit of rewriting because it's not in the power rule form, but this is 3x to the negative 1. So if I do the power rule, I'm going to get negative 3x to the negative 2, which is negative 3 over x squared. If I rewrite it with positive exponents, which is nice when you have to plug in things because positive exponents are easier. All right, now I want to plug in my value because I want to know what is the slope of the tangent line at x equals 1. And I get negative 3. All right, so the slope of the tangent line is negative 3. I have my point. Now I put it in point slope form. Y minus my y value, my slope times x minus my x value. distribute, I add 3, and I get this equation of my tangent line in slope-intercept form. All right, so you can see the process is similar. You just have to know you're plugging 1 in to stuff, but for your point, you're plugging 1 into your original function. For your slope, you're plugging 1 into your derivative. All right, here's one for you to try on your own. All right, find this tangent line, all right, like we just did in our 2 examples. All right, I'll show you the answer in 3, 2, 1. And the final answer I got was 9x minus 16. Again, just a quick recap. You plug in that x value 2 into your original function to get your point. You take the derivative, you plug that value 2 into your derivative to get your slope. And now it's just slope, point slope form, solving slope-intercept form. All right, so quick recap. To find the equation of the tangent line, you need a point and a slope. So that's kind of important, so you know the 2 things you're trying to find. And the point comes from the original function, like your f of x. And your slope comes from the derivative function, your f prime of x. Right, but for both cases, you're just plugging the same x value in once you have those equations.